Hi everyone, in this video I'm continuing to look through question 16 part B of the Baulkham Hills Extension 2 2020 trial exam. So I've just worked through part 1 in a separate video, so have a look at that if you haven't already. Here in part 2 we're told let fx equal x to the k plus 1 minus k plus 1x plus k, where we're told x is positive and k is a positive integer. That's what that fancy Z is, integers, with the plus meaning positive integers. And we're asked to show that fx will be greater than or equal to 0. And before I jump in, it's worth noting the similarity in, I guess, the structure of this function fx and what we just worked through before. Here we've got something to the k plus 1 minus k plus 1 times something plus k. And up in part 1 that we worked through, we saw we had lambda k to the k plus 1 minus k plus 1 lambda k plus k. So you can kind of see how these items are somewhat linked and they're leading somewhere, which is eventually obviously going to be part 3, where we're asked to prove the AMGM inequality. But we'll get to part 3 eventually. For now, let's just focus on part 2. So yeah, let's take a look. So I've just written up the function that we're given, and what we're being asked is to show that fx is greater than or equal to 0. And I think what makes this question tricky is we're not really given you know, any clue or any hint as to how we should go about this. Now we're given I mean, this is part 2, and in part 1 we proved an inequality, and you know, many students might be tempted to think, well, I've got to follow on from that inequality. This thing follows the same structure. Surely I'm just following on. But I think the tricky part with this question is that's not the technique we need to use. I think the technique that hopefully you've got in your toolkit is to know that a function is always greater than or equal to 0. One way that would be the case is if it has only one turning point, and at that turning point the function is above 0 and it's you know, a minimum turning point. So for example, if I was just to draw a really simple curve, and we have x on our x-axis, and we're plotting fx. Here we're told x is greater than 0, so we really only care about this part here. But you can kind of see how if you had a curve that would say a parabola, right? That kind of say it turns at some point on or above the x-axis, and if that's the only turning point, you know it's never coming back down. So it's just going to keep going, and in theory it'll keep going in this direction too, although for this question we only care about x positive, greater than 0. But yeah, it's kind of a very simple idea. If you've got a curve that's only got one turning point, it's a minimum turning point, and that turning point is on or above the x-axis, you can then conclude it's always got to be above 0. So I think that's the process we can go through. So really we're just using very, very basic calculus. Just find the first derivative to get the turning point, set it equal to 0, and then use the second derivative to determine whether it's a max or min. So I guess step 1 is to find the first derivative, f dash x, and this is not a hard function to differentiate. We're using the very first rule of differentiation you would have learned, bring the exponent down, subtract 1. So we're going to get k plus 1 x to the k plus 1 minus 1, or just k, and then minus k plus 1, and then the x will disappear. So we have a turning point when f dash x is equal to 0. So what's that going to be? That's going to be k plus 1 x to the k minus k plus 1 is equal to 0. So if I bring this over, we'll get k plus 1 x to the k equals k plus 1. If I bring the k plus 1 down, we get x to the k equals k plus 1 on k plus 1. We'll just cancel to give 1. And the number of solutions you get I guess you could argue if k was even, you get plus or minus. You could get, for example, plus or minus 1 squared if k was 2, for example. But here, we can just take the positive solution. So we can just say x is 1, because 1 to the anything is still 1, since we're told x is greater than 0. So we don't need to be worrying about negative solutions. We only care about the x greater than 0 solution, which will be 1. Okay, so when x is 1, what is fx? When x equals 1, fx, or f of 1, is equal to 1 to the k plus 1 minus k plus 1 times 1 plus k. So that's just going to be 1 minus k minus 1 plus k. So the 1 and minus 1 cancel. The minus k and the plus k cancel, so we get 0. So we say, therefore, we have a turning point at 1, 0. Or kind of like how I drew here, it's basically 1 and on the x-axis. But that's okay, because we've got an includes in our inequalities, so greater than or equal to 0. So we've got our turning point at 0. Is it a max or a min? If it's a minimum turning point, it's good news. If it's a max, well, we're in trouble. So you kind of know it's going to be a min, but you have to show it. So to do that, we find the second derivative. So the second derivative, f double dash x, will be, we'll bring our k down. So we'll get k times k plus 1, which was already there, and then x to the k minus 1, and then this will drop away. So the question is that positive? Now we know k is a positive integer, and we know x is always positive. So actually, this is going to be positive, and we can say since x is positive, so no matter what we put in here, we end up with a positive number. And we know k is in the positive integers. So therefore, it's a minimum turning point. So maybe if I just make a little bit more space, we can say, therefore, fx is greater than or equal to 0, since only one turning point at 1, 0, and it's a minimum turning point. I think if you kind of laid all that out, that's probably enough for a marker to say, yep, you get the marks. You understand why fx must always be positive. So, you know, maybe my wording's not the best there, but actually you'd hope it would be good enough. So yeah, that's how you tackle that question. Again, as I hinted at or mentioned earlier, I think it's a tough question because you're not given any scaffolding or any guidance to kind of say, do this, you know. A nicer question writer might have said, by considering, you know, the turning points of fx or something like that. Something to just at least hint, use calculus. In the absence of that hint, you've just got to hope that you've seen similar questions before and that this kind of technique is in your toolkit. So if it wasn't before, hopefully it is now, so that if you were to encounter another question like this in another exam, hopefully, you know, you'd remember this and have half a chance of you know, using this technique. All right, so now that leaves just part 3, which I'll take a look at in the next video. All right, tick boom.